I hope you're all good. Okay, generally, we have quite a whole lot of stuff to do this night. We will be looking at organic chemistry from where we stopped in organic chemistry, and then we also try as much as possible to, under the organic chemistry, we look at, the alcohols. A very interesting topic that we'll be doing in this particular session. So I want you to, be active. Try not to, be distracted. Just try to be very, very attentive. And I believe that, you get a whole lot from this particular interaction. Okay. Just give me a minute. Let me get some stuffs ready up. Okay. Up and ready. Okay. Okay, now I want us to look at organic chemistry, which is Chem 101, right? That's what we're still looking at in this conversation. Now, the other time I was talking about alkanols. Now, I didn't finish up on the alkanols before we, stop the class. So I want us to look at alkanols. Now, when we're talking about alkanols, alkanols have this functional group ROH, right? Where R is the alkyl group and O is the what? Alcohol functional group, which is OH. So you can write R-OH. That's how we usually write. So in this scenario now, what we're going to do is, what is now alkyl group? Alkyl group, whenever we're talking about alkyl group, I want this stand to stand on its own, so just give me a minute. Okay, whenever we're talking about, I believe this is okay now. And whenever we're talking about alkyl group is something like CnH2n plus what? Plus 1. This is the general formula for what? For alkyl group. So in this situation, when we're talking about alkanols, you say that alkanols is what? ROH. So that means generally I can have, alkanols like, when I have one carbon, I will have CH3OH. I would do that. This is an example of a methanol. Methanol, right? Methanol. Because here I will have C1, 2 times 1, 2 plus 1, 3. So CH3, and then I'll add OH. Are we together now? So in a nutshell, if I want to write this particular alkanol formula, I can simply write alkanols is the same thing as, anywhere I see R, I'll put CnH2n plus 1. I'll just put CnH2n plus 1. Now I'll add OH, right? So if I want to write ethanol, what's the molecular formula for ethanol? Now, right, anywhere I see N, what am I going to put in N? This particular N now will represent, the number of alkane group. So if this is 2, now I'm going to say C2, H 2 times 2 is 4. You understand? So now plus 1, which is 5. So it's going to be C2H5OH, right? This is what? This is ethanol. Are we together now? Don't worry, you will not fail chemistry again. This will be the last time you fail chemistry, right? Peroxychemate. This will be the last time you fail this chemistry. We are awake tonight doing this, so I believe that we'll do well. So just focus and don't be distracted. So now, this is ethanol, right? C2H5OH. Now, we also have propanol. Propanol will be here, will be 3 now, because we have met, et, prop, are we there now? But, pent, hex, hept, oct, non, dec. So 1 is met, 2 is et. Are we together now? 3 is prop, 4 is but. Say, if you join me in my organic chemistry, you know that when n is equal to 1, we're looking at met. When n equal to 2, we are looking at what? Et. This et can be methane, ethane. When n equals 3, we're looking at prop. Are we there now? When n equals 4, I will stop at 5. We're looking at pent. When n equals 4, sorry, we're looking at but. Are we there now? Now, when n equals 5, we're looking at what? Pent. Are we in order now? So in this situation now, what we are going to do is that I've gotten for my ethanol. Now, let me check for my propanol when n is 3. So I will now use this formula. Anywhere I see N, I'll put 3. So I'm going to use the formula CnH2n plus 1 OH, right? Anywhere I see N, when N is equal to 3. Anywhere I see N, what am I going to put? I'm going to put 3. So I'm going to say C3. 3 times 2 is what? 3 times 2 is 6. So I'm going to say C3 plus 1, 7. So I'm going to say C3H7OH. This is a typical what? Propanol. Are we there now? Now, if I want to do when N is equal to 4, I will also use the formula C4H2 times 4, 8 plus 1, 9. So C4H9OH. That's what? Butanol. Are we there now? Now, if I want to do for my pentanol, I will say anywhere I see N, I'll put 5. C times 5, C5. 2 times 5, 10. Plus this one, 11. So I'm going to say C5H11OH. That is what? That is pentanol. So I want to stop here. Now, let's look at the types of alkanols. Types of what? Types of alkanols. Now, when we're talking about types of alkanols, there are 3 types of alkanols that we must, follow suit in this particular session. Types of alkanols. If you don't call it alkanols, you call it alcohols. Types of what? Alkanols. Now, there are 3 major types of alkanols. We have number 1, we have monohydric alkanols. Monohydric alkanols. Number 2, dihydric alkanols. I will look at them one after the other. Don't be distracted. Dihydric alkanols. Number 3, trihydric alkanols. They usually ask this question in jump pass questions. Trihydric alkanols. Now we'll explain. Let's look at monohydric. Now look up. When we're talking about monohydric alkanols are alkanols that has one OH group. Monohydric alkanols are alkanols that have what? One OH group. Monohydric alkanols are alkanols that has what? Are alkanols that have what? One OH group. What is OH? OH is the functional group. They have what? One OH group. They have one OH group. Are we together now? Now, whenever we have one single OH group in that particular alcohol is what? A monohydric. For example, C, OH, H, H. This particular alkanol is a monohydric. Why is it monohydric? Because it has what? One OH group only. Are we together now? So the name of this particular alkanol is what? Now you say ethanol, or you say ethan 1 or, are we there now? Or 1 ethanol. Are we together now? Now, when we move on to other types of monohydric, there are 3 major types of monohydric alkanols. 3 major types of monohydric. Now, the first one is primary alkanols. We have primary. Second one, secondary. Are we there now? And the next one is what? Tertiary alkanols. Okay, Samuel, I can see you. Welcome. Don't be distracted. Focus. Now we have what? Tertiary alkanols. I say we have primary, secondary, and what? And tertiary alkanols. Now let's look at primary alkanols. I've already explained monohydric. I said that monohydric alkanols are alkanols that have what? One singular OH group. There are a lot of them. So far as it has one singular OH group, it is called what? A monohydric alkanols. Are we together now? Now, if you come to primary alkanols, which is under monohydric, primary alkanols are alkanols whereby the OH, let me explain. Primary alkanols are alkanols that has the OH, have the OH group attached to the primary carbon atom. I have the OH group attached to the what? Primary carbon atom. Now, what is primary carbon atom? A primary carbon atom, you can write down, a primary carbon atom is that particular carbon atom, are we together now, that is attached to only one single carbon atom. It is not attached to two carbon atom, but just one single carbon atom. Are we together now? I say a primary carbon atom is a carbon atom that is attached to only one carbon atom. Are we together now? That's what? A primary carbon atom. So when we have the OH group attached to that primary carbon atom, that particular alcohol is called what? A primary alcohol. Let me give you an instance. If I have something like this, C, and then I have OH, I have H, I have H, I have H, H, and then I have H. Now, we say that a primary alkanols is that particular alkanols, whereby the OH, which is the functional group, is attached to the what? Primary carbon atom. And I say that the primary carbon atom is that particular carbon atom that has only one carbon atom attached to it. This is a primary carbon atom. Why is it a primary carbon atom? Because it has only one carbon atom attached to it. Look at this particular carbon atom. What is attached to this particular carbon atom? OH, H, carbon, and H. So that particular carbon atom that has only one carbon atom attached to it, are we there now? That it doesn't have two carbon atoms, just one carbon atom only attached to it and every other substituent. That carbon atom is what? A primary carbon atom. So this is PC. What is PC? Primary carbon atom. So when the OH group is attached to the primary carbon atom, that particular alkanol is what? A primary alkanol. This is also a primary carbon atom. Why is it a primary carbon atom? Because in the carbon atom, we have hydrogen surrounding it, and one carbon atom. So this is a primary carbon atom. This is what? A primary carbon atom. The first and the last carbon atom are usually the primary carbon atoms. Are we there now? The first and the last carbon atoms are usually the what? The primary carbon atom. So in this scenario now, this is primary carbon atom. This is also what? Primary carbon atom. So whenever the OH group is attached to here or here, first or last, are we there now? That particular alkanol is called what? A primary alkanol. Let me give you another example. What's the name of this? This is propan 1-O. This is propan 1-O. Now, I can also have something like this, C, and then I have OH, H, and H. Are we together now? Now, in this scenario, I have OH group. This is the functional group OH attached to this particular carbon atom called what? Primary carbon atom. So when the OH group is bonded to the primary carbon atom, that alcohol is called what? A primary alcohol. So this is the primary carbon atom, the carbon atom that has only one carbon atom bonded to it. There are other substituents, but the only carbon atom bonded to it is just one carbon atom. So that particular carbon atom is called what? Primary carbon atom. So when the OH group is bonded to a primary carbon atom, that alcohol is called what? A primary alcohol. So this is primary carbon atom. I told you that the first and the last are primary. So this is also what? Primary carbon atom. Are we together now? So we are done with primary alkanol. So what's the name of this particular man? I will start naming. 1, 2, 3, 4. So the name, the IUPAC name of this alcohol is Boots 1-O. Are we there now? Now let's move on to secondary alkanols. If you have a question, ask on the chat, so I'm reading it. So ask your questions. So this is secondary alkanols. Let's move to secondary alkanols. I've just explained primary. Secondary alkanols. Now remember that I told you that we have 3 types of alkanols, which are monohydric, dihydric, and what? And trihydric. Are we there now? Monohydric, dihydric, and what? And trihydric. Now, in this scenario, I've just explained monohydric. I said that monohydric have what? One OH group. Monohydric have what? One OH group. Are we together now? That's monohydric. Now, if we come to, the next particular, next particular type of alkanols, I told you that before we move into dihydric, let's first of all finish up with monohydric. And under monohydrate, we have primary alkanols, secondary and tertiary. I say that for primary alkanols, they are alkanols that have the OH group attached to the what? To the primary carbon atom. And what is the primary carbon atom? A primary carbon atom is that carbon atom that has only one carbon atom bonded to it. Are we there now? So I mentioned when the OH group is attached to the primary carbon atom, that particular alcohol is what? A primary alcohol or alkanols. Like here, like here. The first and the last carbon atoms are usually the what? The primary carbon atom. The first and the last carbon atoms are usually the what? The primary carbon atoms. So let's move on to secondary alkanols. Now, under secondary alkanols, you need to understand that in secondary alkanols, we are also saying that these are alkanols. Are we there now? Now, that have their OH group that has the OH group attached to the secondary carbon atom. Attached to the what? Secondary carbon atom. Attached to the secondary carbon atom. Now, let me explain. Look up. Now, when we're talking about secondary carbon atom, a secondary carbon atom is that carbon atom that has two other carbon atoms attached to it. That has how many other carbon atoms? Two other carbon atoms attached to it. Are we together now? So something like this. If I have C, and C. Now, this particular carbon atom in the middle is called what? A secondary carbon atom. Why is it a secondary carbon atom? Because it has two other carbon atoms attached to it. The last one here is primary. This one is primary. But this one at the middle is what? Is secondary. Are we there now? Why is it secondary carbon atom? It is a secondary carbon atom because it has two other carbon atoms attached to it. If I also have something like this, C, this is a secondary carbon atom. Are we there now? Why is this a secondary carbon atom? Because it is in between two carbon atoms. So it has two carbon atoms attached to it. This one also is a secondary carbon atom. Why is it a secondary carbon atom? Because it has what? Two other carbon atoms attached to it. So this is a secondary, SC, secondary carbon atom. This is SC, secondary carbon atom. This is what? SC, secondary carbon atom. So when the OH group is attached to this particular secondary carbon atom, that alkanols is called what? A secondary alkanol or alcohol. I don't know if you're getting what I'm saying. So if we come here and then we have something like this, maybe I have, say, maybe C. Okay, let's do it on a separate place. Let's I have C, and then I have OH, I have H, and then I have H, and H. Now, because the OH group is at the middle, that means it's at the secondary carbon atom. What is a secondary carbon atom? A secondary carbon atom is that carbon atom that is attached to two other carbon atoms. So this is secondary. The second carbon atom here is secondary. Are we there now? This one is primary. This one is primary. So when the OH group is attached to the secondary carbon atom, that alcohol is called what? A secondary alcohol. So what's the name here? This is propan 2-O. Propan 2-O. Are we together now? So this is an example of a secondary alkanol. Now, I will also give you another example. Say I have something like this. C, 3, 4, 5, 6. Now, already, because this is this is primary carbon atom. This is primary PC, primary carbon atom. This is primary carbon atom. If I have OH attached here or here, first or last, this alcohol will be primary. But if I have OH attached here, it will be secondary alcohol. Why will it be secondary? Because this carbon atom is what? A secondary carbon atom. Why is it a secondary carbon atom? Because it has what? Two different carbon atoms attached to it. So if I have OH attached here, or OH attached here, or OH attached here, or OH attached anywhere between this particular carbon atom in the middle, that alcohol is what? A secondary carbon atom, or a secondary alcohol rather. Why is it a secondary alcohol? It's a secondary alcohol because the OH group is attached to the what? Secondary carbon atom. Are we there now? So if I ask you what is the name of this compound, you're going to tell me this is 1, 2, 3, hydrogen, everywhere hydrogen, hydrogen. Here OH hydrogen, here hydrogen, 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 hydrogen. So if I'm naming, I will start from here. 1, 2, 3, 4, 5, and 6. So I will say hex 2-O. Are we there now? So hex 2-O, is it a primary, secondary, or tertiary? It is what? A secondary alcohol. Why is it a secondary alcohol? Because the OH functional group is attached to the what? A secondary carbon atom. Remember, a primary carbon atom is that carbon atom that is only bonded with a singular carbon atom, another substituent. A secondary carbon atom is that carbon atom that is bonded with what? Two different carbon atoms. Are we together now? So when we have OH bound to that particular secondary carbon atom, that alcohol is what? A secondary alcohol. Now let's move on to tertiary alcohol. Tertiary alcohol. Now in tertiary alcohol, what are we saying? We're saying that this alcohol is formed when the OH group is bonded towards a tertiary carbon atom. Bonded towards a tertiary carbon atom. Are we together now? When the OH group is bonded to what? A tertiary carbon atom. Now, what is a tertiary carbon atom? If primary carbon atom, we're talking about a carbon atom that is attached to one carbon atom. Secondary carbon atom is that carbon atom that is attached to two other carbon atoms. Now, what is tertiary? A tertiary carbon atom is that carbon atom that is attached to what? Three other carbon atoms. Are we there now? So, example of a carbon atom that is tertiary is something like this. C. Remember, this is primary, this is secondary. But if I add a new C here, and then I have H, here should be OH, and then I have H, and H. This is a tertiary carbon atom. This is TC. Why is it TC? Because it has carbon here, and carbon here. Any carbon atom that is bonded to three other carbon atoms, that particular carbon atom is what? A tertiary carbon atom. Any carbon atom that is bonded to two other carbon atoms, that particular carbon atom is what? A secondary. Any carbon atom that is bonded to one carbon atom, that carbon atom is what? Primary. So in this scenario now, this is a tertiary alcohol because the OH functional group is attached to the what? Tertiary carbon atom. So if I want to name, I will name 1, 2, 3. I will say 2-methyl propan 2-O. 2-methyl propan what? Propan 2-O. 2-methyl propan what? Propan 2-O. Are we together now? I can also give another example of a tertiary alcohol. A tertiary alcohol can be found from here. I will say C, and then I'll come here, I'll write C, and then I'll have OH. I will have here H. Are we together now? I'll have here H. If I want to name, I will say 1, 2, 3, 4. I'm starting here because of the OH group. I'll make sure that the OH group has the lesser number. So I will start from here. So if I start counting from here now, this is my primary carbon atom. This is what? A tertiary carbon atom. Why is it a tertiary? Because it has carbon 1, carbon bonded to it. It has 3 carbon atoms. So when the OH is bonded to this particular tertiary carbon atom, this alcohol is called what? A tertiary alcohol. So in this scenario now, this is 2-methyl. Now 1, 2, 3, 4. Boots 2-O. Are we together now? So I've explained primary, secondary, and tertiary alcohol. Now I want us to look at dihydric alkanols, which is an important concept. Dihydric alkanols. Dihydric alkanols. I've explained monohydric. I said that monohydric, what we are saying is it must have what? One OH group. It must have what? One OH group. That's monohydric. Go through this and let me know if you have any question. All right. Now, for this particular dihydric alkanols, now dihydric alkanols are generally alkanols that has 2 OH group. As you can see, di simply means 2. Hydric, OH. So when we have 2 OH groups, are we there now? That alkanols are called what? Dihydric alkanols. So if I come here and then I have something like this, sorry about that, my stand is disturbing me a bit, but let's arrange it. Okay. Okay. So if I come here and then I have something like this, say for instance, okay. So let's take for instance, I have maybe C, and then I have OH, When we have 2 OH group in a particular alcohol, that particular alcohol is called what? A dihydric alcohol. Are we there now? It is a dihydric because it has what? 2 OH group. If it has 1 OH group like we've been doing, explaining primary, secondary, and tertiary, it would have been what? A monohydric. But once it has 2 OH group, it is called what? A dihydric alkanols. Are we together now? It must not go beyond 2, just 2 OH group. It is called what? A dihydric, like this particular man here. If I'm naming, I will say 1, 2, 3, and 4. Are we there now? Now remember, all these particular places are hydrogen. So in this scenario now, if I want to name, the family is 4. So I'm going to say but 1, okay, not 1, 2, but 2, 3 diol. But 2, 3 diol. Are we there now? This is an example of what? A dihydric alkanol. A dihydric alkanols are alkanols that has what? 2 OH groups. Are we there now? Monohydric alkanols are alkanols that have what? 1 OH group. So but 2, 3 diol is an example of what? Of a dihydric alkanols. Whenever you have OH group present in a specific alkanols, that alkanol is what? A dihydric. You can look at another example here. Like when we have C, and C. And then I have something like this, OH, and I have also OH. Now, if you see, the OH came in the same carbon. It doesn't matter the order, but so far as we have 2 OH group in that particular alkanol, it makes it what? A dihydric. So all these places will be hydrogen. So I'll count. This will be 1, 2, 3, 4, 5, and what? And 6. Please, if you can hear me, use the comment box. If you are following, if you can see what I'm doing here, use the comment box and drop a comment. Let me know that you're following. So in this scenario now, this is going to be 1, 2, 3, 4, 5, 6. So because it's 6, the family name is hex. So I'm going to say hex 2, 2 diol. Are we there now? Hex 2, 2 diol. Are we there now? That is as simple as ABC. Hex 2, 2 what? 2, 2 diol. So this is an example of what? Of a dihydric alkanols. Now, of a dihydric alkanols. Now, when we're talking about trihydric. In trihydric alkanols, we are saying that these alkanols, whereby we have what? 3 OH group. Whereby we have what? 3 OH groups. Are we together now? When we have what? 3 OH groups. Trihydric alkanols. We're talking about what? 3 OH groups. 3 OH groups. Say for instance, something like this. C, and then I have OH, and then I have H. Now, if I'm counting, I'm going to start from here. 1, 2, 3. Anywhere I start from, it's still the same thing. Are we there now? Okay, you're following. Okay. Glad. Good. Okay, let's continue. Yes, so in this scenario now, if you look at this particular, alkanol, this is a trihydric alkanols. Why is the trihydric? Because it has what? 3 OH group. OH1, OH2, OH3. Are we together now? So if I'm going to name this particular alkanol, I'm going to say, because the family is 3, so this is, you either say 1, 2, 3 tripropanol, or you say propan 1, 2, 3 triol, which is as simple as ABC. Are we there now? Propan 1, 2, 3, triol. Are we there now? Propan 1, 2, 3 triol. Are we together now? So whenever we have 3 OH group arranged in a particular, structure, we know that that particular alcohol is what? A trihydric. When we have 1 OH group, monohydric. When we have 2 OH group, dihydric. When we have 3 OH group, trihydric. When we have OH attached to the primary carbon atom, primary alkanol. When we have OH attached to the secondary carbon atom, secondary alkanols. When we have OH attached to the tertiary alkanols, it is what? Tertiary alkanol. What is the primary carbon atom? The primary carbon atom is that carbon atom that is bonded with what? Only one carbon atom and another substituent. What is a secondary carbon atom? A secondary carbon atom is that carbon atom that is bonded with 2 carbon atom and other substituents. What is a tertiary carbon atom? A tertiary carbon atom is that carbon atom that is bonded to 3 other carbon atoms and other substituents. Are we together now? So in this scenario, we are done with what? Alkanols. Now, I want us to try as much as possible to enter into another, organic compounds that I call alkanoic acids. Alkanoic what? Alkanoic acids. Are we there now? Alkanoic acids. Now, what is the general formula for alkanoic acid? Alkanoic acid are RCOOH. Are we there now? That's formula for what? Alkanoic what? Acids. RCOOH. Now, they can ask you to draw the structure. In exam, this is how it looks. RC. Now, you say double bond. Are we there now? Double bond O and then OH. Are we together now? This is a simple structure of what? Of an alkanoic acid. R, single bond C, double bond O, single bond what? OH. This is an alkanoic acid. Remember, the R is what? An alkyl group. Are we there now? So when I have something like this, CH3, COOH. Now, how we usually do for alkanoic acid is that we use the number of carbon atoms to determine the name of the acid. So if I have 2 carbon atoms here, remember that when carbon atom is 2, it is X. So what the name of this particular acid is going to be what? Ethanoic acid. I would an ethanoic acid. Because I already have methyl plus COOH. It is what? Ethanoic acid. We don't use CH3 as say is methanoic. No. It's what? Ethanoic acid. So if I have something like C2H5COOH. Now, this is ethyl. Ethyl plus C will be propyl. So this is going to be what? Propanoic acid. Propanoic acid. Are we there now? Now, if I have C3H7COOH. Now, do you know the name of this? This is going to be propyl plus C. It is going to be but. So this is what? Butanoic acid. Are we there now? Now, if I have C4H9COOH, this is going to be but plus C, which is pentanoic acid. Pentanoic what? Acid. Are we there now? So let's look at the simple structure of this alkanoic acid. Let's start with ethanoic acid. In ethanoic acid, I'm going to have CH3, H, this is H, this is H, this is H. I've drawn the methyl, and then COOH. This is a typical structure of what? Of ethanoic acid. Are we there now? Ethanoic acid. In case you see it in exam, you will first of all write out the methyl and then COOH. Are we together now? So this is an ethanoic acid. Now we can also have something like this. Is number 1. Look at number 2. I can have C2H5. H, and then I have C double bond O, OH. This is a typical what? Propanoic acid. This propanoic acid. Are we following? So when we're talking about RCOOH, those are what? Alkanoic acid. And I've given you an example what they look like. Are we there now? So a typical example is R methyl plus COOH will turn to what? Ethanoic acid and not methanoic acid. Are we there now? If I have R, which is ethyl plus COOH, it will turn to what? Propanoic acid. Are we there now? So when I have R, which is propyl plus COOH, it will turn to what? Butanoic. Why will it turn to butanoic? Because this is C3 plus 1 carbon in COOH, it will be what? 4 carbon, which is butanoic. Are we there now? This is C4 plus 1 carbon in COOH, which is what? Pentanoic. Are we following? Are we together now? So in this scenario, this is, the structures of alkanoic acid, what they look like. Okay. Now, let's try as much as possible to, finish up. If we do propanoic, let's look at butanoic. Butanoic could be C4H9COOH. So I'm going to say C. Are we there now? C4. So it's going to be C3. Let's say C4. H9, this is H3, H4, H5, H6, H7, H8, H9, and then they say COOH, C double bond O, single bond OH. Now, this is a typical example of what? This is C4, 1, 2, 3, 4, plus 1, 5. This is pentanoic acid. This is pentanoic acid. Because it's when butyl plus COOH comes together, they form what? A pentanoic acid. So that is that about, alkanoic acid. So when I mention alkanoic acid, you should know that alkanoic acid has the general molecular formula RCOOH. Are we there now? And you know what R means? R is an alkyl group. But when we get that singular alkyl group, say for methyl, it's not going to be methanoic acid. It's going to be methyl plus the C in the functional group, which will turn to what? Et. If I have ethyl, I'm going to say et plus the C, which is in the functional group, is going to be propanoic acid. If I have prop, which is the ethyl plus C in the functional group, is going to be what? Butanoic acid. You continue like that, up until you get to the point of what you are, solving for. Are we done now? So we're done now. I want us to look at, what we mean by ethers. That are what we call ethers. Is also another, organic compound, ethers. Now, ethers are formed from the combination of what? Two alkyl group that are held together by a single oxygen atom. Ethers are formed from the combination of two alkyl group that are held together by what? One oxygen atom. That's the general formula of ethers, ROR. Are we there now? So ethers are formed when we have two alkyl group. If you don't call them alkyl group, R is the same thing as alkyl group, alkyl or RI group, and their formula is what? CnH2n plus 1. Are we there now? CnH2n plus what? Plus 1. So when we have, this is an ether. So when ethers are ROR. Are we together now? So when we have, say for instance, you have, let's say RCH3 OCH3. Are we there now? So CH3 OCH3. When we have this particular compound, this is an ether. So far as oxygen is separating these two R groups, it is called what? An ether. Now, what is the name? This is what? This is dimethyl ether. Dimethyl what? Ether. Or you say ethyl, or you say methyl ether. Are we there now? This is dimethyl ether, or you say methyl ether. If I have something like this, C2H5 O C2H5. This is what? Ethyl ether. Are we there now? Ethyl ether, or you say diethyl ether. Already you know how we form our ethyl using the general formula CnH2n plus 1. Are we there now? So this is diethyl ether. Now, I can also have something like this, C4H9O C4H9. These are butyl ether, or you say what? Dibutyl ether. So whenever you have two R group, the name is what? Dibutyl ether. Dibutyl ether. So whenever we have two R group that is separated by a singular oxygen atom, that particular compound is what? It's called an ether. So that is why we have formula ROR. Are we together now? Okay, if you're following, please send a message. Let me know that you are here, you're following. Are we together now? If you're following, just send a message across. Now, the next thing I want us to look at is esterification. Esterification, I just want to, make this make sense as much as possible. Esterification. I don't know if you've heard of esterification. Esterification. Now, generally, esters are formed from esterification. Are we there now? So, esters are generally formed. Are we there now? Esters are generally formed from esterification. Esters are formed. I'm coming. Let me arrange a stand. So esters are generally formed from what? Esterification. Now the question is, what is esterification, or what are esterifications? Now when we're talking about esterification, now esterification is more like when we have maybe alkanoic acid, react with an ethanol. Are we together now? To form, or alkanols, to form, an ester and water. Are we there now? So esterification, look at the esterification reaction here. This reaction of esterification, let me show you. When we have, say for instance, we have something like this, maybe let's say alkanoic acid, are we there now, plus let's say alkanols. Are we there now? Alkanoic acid plus alkanols. Now to try as much as possible to form esters and what? And water. Are we there now? This particular reaction is called what? Esterification. Now let me use an example of an alkanoic acid. Let me use ethanoic acid. Now what is ethanoic acid? CH3. Remember from our conversation, CH3. I'm coming. Let me arrange my stand a bit. Okay. So now in this situation, now let's take for instance we are having CH3 COOH. Are we together now? Now CH3 COOH is what? Is an ethanoic acid. Now ethanoic acid plus, let's use an ethanol. Are we there now? Which is C2H5OH. Are we there now? Now we're going to form an ester. Are we together now? Now the ester we're going to form is ethyl ethanoate. Ethyl ethanoate, I'm going to have something like this, CH3 COO C2H5 plus H2O. So this is what? An ester. This CH3COO C2H5 is what? An ester. Are we together now? Why is it then an ester? Now let me show you. Now when we're talking about esters, look at the general formula for esters. Esters have the general formula RCOOR. Are we there now? RCOO, or you say RCOOR prime. Are we there now? And let me take back this ethyl ethanoate. Look up. And I told you that ethyl ethanoate is CH3 COO C2H5. I want to teach you how to name these particular esters or alkanoids. If you don't call them esters, you call them what? Alkanoids. Now I want to teach you how to name these alkanoids. so that you listen. Now look up. Now remember that esters is RCOO R prime. And I told you that R is what? An alkyl group. R is what? An alkyl group. So that means what comes in between these two alkyl group is COO. Unlike ethers, we have ethers and we have esters. In ethers was ROR. The only thing that came in between was O. But in this scenario now, what came in between is what? COO. So if I'm naming esters, I start from the back. This is front. This is back. So whenever I'm naming esters, I start from the what? I start from the back. RCOO R prime. This is where I start from. I start from the back to name. Are we there now? So in this situation now, if I have something like this, CH3COO, what I will do, I will leave this particular man separate. Are we there now? I will first of all bring out this man. What is C2H5? C2H5 is ethyl. Are we there now? If I have ethyl, and then I have methyl with COO. So, but because this particular, I already tell you that when we're talking about functional group, we must add the carbon atom. So, but because I have this COO in between here, I'm going to take one carbon atom and add here. It will be eth. So it will now be ethyl from the back. Instead of ethyl metanoate, it will be ethyl plus methyl. And then I will take methyl and I add another carbon atom to methyl to form another ethanoate. So that's why we have ethyl metanoate. If I have something like this, CH3, COO, C3H7. Now, what is the name? Well, first of all, identify C3H7 is propyl. This is propyl. Are we there now? So because this is propyl, I will have methyl here, right? This is CH3, methyl. If I add a new carbon atom to this methyl, it will be eth. Are we there now? So this will be propyl ethanoate. Propyl from the back, remember, propyl ethanoate. Propyl ethanoate. Methyl plus a new C will form what? Eth. I don't know if you are following. I hope you are. Now, if I have something like this, C2H5, COO, CH3, what is the name? I want you to write the name in the comment box and let me know. Can you try it? I said we name from the back. If you name from the back, what will it be? Remember, COO, you are going to add C to this particular man here. What is the name? Someone should give me the name. I'm waiting. You have 30 seconds. Jam will not give you 2 days. Okay. Let me come in. Now, if we name from the back here, this is methyl. Are we there now? So this is methyl. We got it right. This is methyl. Now, this is ethyl. Are we there now? This is ethyl. I'm naming the two R groups. This is ethyl. This is methyl. This is ethyl. Are we there now? Okay, methyl ethanoate. You tried, but you didn't get it though. So, but look up. This is ethyl. This is methyl rather. This is ethyl. Are we together now? So I told you we name from the back. So I'll start with methyl. Now, but because we have ethyl, and I told you that this carbon atom will not leave it like that. We'll add this carbon atom here. So it will be methyl propanoate. Propanoate. Not methyl ethanoate. Is methyl what? Propanoate. Because we add ethyl plus 1 carbon atom, it will turn to 3 carbon atom. What is 3 carbon atom? Is prop. Are we there now? So it's methyl propanoate. If I have something like this, let's say C4H9, COO, C2H5. What will be the name? Now the name will come from here. This will start naming from the back. This is ethyl. Are we there now? We'll write down ethyl first. Now we'll come here. C4 is boot. If I take 1 carbon atom from COO to add, it will be pent. So it will be ethyl pentanoate. I believe you are getting what we are doing here. These are esters or alkanoids. If you don't call them esters, you call them what? Alkanoids. Now, let me ask you this question. What if you have something like this? Say you have, maybe, let me use C2H5COO, C3H7. Give me the name. 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 What will be the name here? C2H5COO, C3H7. Let me know those that are following. If you have C2H5COO, C3H7, what will be the name now? Okay, propyl propanoate. Amazing. Because already here, this is what? This is propyl. Are we together now? And then this is et. First of all, I told you we start naming from the back. So this is propyl. Are we there now? And then this should be et. Et plus 1 carbon, propanoate. Thank you, you are following. So this is propyl propanoate. Propanoate. Are we there now? So these are the simple esters that you can actually go. If you go beyond, maybe if you want to, go above and beyond, when we begin to look at fat and oils. In fat and oil, these are, if you look at these esters, they have smaller carbon atom. You can have esters whereby you have something like this, C15, CH31, COO, and then you have C15H31. These are esters of long chain. These are the ones we call, lipids. Like your fats. Whenever you have esters of long chain, we call them what? We call them what? Lipids. In this situation, this is C15. Remember, I told you that 1 is methane. Let's count to 20 now. Listen to me. Let's go together. Methane, ethane, propane, butane, pentane. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. 10 is decane. I'm giving you time to know if you can get this name. 10 is decane. 11 is undecane. 12 is dodecane. 13 is tridecane. 14 is tetradecane. 15 is pentadecane, 16 is hexadecane, 17 is heptadecane, 18 is octadecane, 19 is nonadecane, 20 is icosane. This is the icosane, E-I-C-O-S-A-N-E. So this is what? Icosane. So if I come here, this is, pentadecane, pentadecane. This is pentadecane. So I will come here. Now, because I have this particular man is alkyl. So I'm going to say pentadecyl. I know this one is longer. Pentadecyl, because it's 15 now. Pentadecyl. Are we there now? Pentadecyl. And then I come here. This is 15 plus 1. It will be 16. So this will now be pentadecyl pentahexanoates. Pentahexanoates. So it's actually in this particular, ester that we use in saponification. And that will be what will be leading us on to what? Saponification. Are we there now? It will be what will be leading us to what? Saponification. Are we together now? Because for you to understand saponification, pentadecyl hexadecanoate. Okay, Emma is right. Hexadecanoate. Pentadecyl. Pentadecyl is what? 15, right? Now, hexa should be 16. Hexadecanoate. Thank you. It should be hexa, not pentahexanoate. Hexadecanoate. Thank you for that. I made a mistake. Hexadecanoate. Because hexadecanoate is 16. 15 plus 1 is 16. Are we there now? Good. So it's pentadecyl hexa what? Hexadecanoate. Thank you so much. Are we there now? So that is it. Now, it's actually in this particular, esters that we use in saponification. Are we there now? Is this esters that we use in what? In saponification. Generally, when we're talking about saponification, what are we talking about? We're talking about alkaline hydrolysis of esters. Are we there now? Especially that of fat and oil. Are we there now? To produce what? Soap and glycerol. When we're talking about alkaline hydrolysis, we're talking about, we're having maybe sodium hydroxide, react with these particular esters of, triesters. I think that's the word, triesters. Long chain, esters. So when we have triester saponification, let me just do a random explanation. Saponification. So when we take this particular, longer esters, are we gonna triesters of them? Triester simply means I can have C15, H31, COO, and then C15, H31 into 3, 1, 2 into 3. And then I react it with 3 moles of, say, this particular man here. I will say, let me use maybe fats plus I will use also 3 moles of sodium hydroxide. Are we getting what I'm saying? So that will form 3 moles of soap. Are we there now? Plus glycerol. Are we there now? Plus what? Glycerol. And I told you that another name for glycerol. What's the IUPAC name of glycerol? Propan 1,2,3 triol, right? That's what the IUPAC name of what? Of glycerol, which is a is it trihydric alcohol? Yes, it's a trihydric alcohol because it has what? It has 3 OH groups. Are we together now? So this is what we mean by saponification. Now, also another organic compounds that you also like to know is what? Aldehyde. Aldehyde. Please try as much as possible to know these functional groups, know their functional groups. Aldehyde is, if you don't call it aldehyde, you call it what? Alkanals. RCHO. Are we there now? RCHO. Now, most of the time, you can see the structure as this R, and then you see C, then you see something like this, double bond O, single bond H. Remember, this particular man is not the same thing with R, single bond C. Look up, don't be distracted. R, single bond C, double bond O, OH. Remember, these two things are not the same. This is alkanals or aldehyde. This is alkanals, where this one is what? Alkanoic acids. Alkanoic acids. Look up. This one is RC, double bond O, and then H. This one is RC, double bond O, single bond OH. They are two different things. Are we together now? They are what? Two different things. This is alkanal. This one is what? Alkanoic acid. So I want us to look at, the alkanals. Now, when we're talking about alkanals, I told you that alkanals, they have what? RCHO as their what? As their functional group. Something that is very, very essential. Say, for instance, I can have, maybe, remember your R is still alkyl. So that alkyl can be C2H5. And then I have CHO. Are we together now? Now, if I want to draw the structure, look at how I'm going to draw the structure. C, remember, C2H5. Are we there now? And then I can have C, double bond O, single bond H. If I want to write, say, what is the IUPAC name of this particular compound? The IUPAC name of this particular compound is propana. Propana or 1-propana. Are we there now? Either say propana or what? 1-propana. Why is it propana? Because of a what? Functional group. And I must start from the functional group to count. Are we together now? Propana or what? 1-propana. Thank you. Am I following? So this is what? A propana, or you say what? 1-propana. Now, also I can have something like this. When I have the alkyl group, say alkyl group of, let's say C, let's use C5, H, let's say H11. I will do now CHO. Now, I will come here, I will write C, 1, 2, 3, 4, 5. And then I'll come here C. I'll write O, and then I have H. H. Now, if I'm naming, I will start from here. I will start naming from here. 1, 2, 3, 4, 5, 6. Are we together now? Now, already the family name is hex. Are we there now? So I'm going to write what? Hexana, or what? Or 1-hexana. Are we together now? So this is a typical example of what? Of alkanals or aldehyde. Are we there now? When naming them, they usually ends with AL. Are we there now? Alkanal. So this is hexana. Hexana or what? Or 1-hexana. Still the same thing. Are we there now? So this is what we call what? An aldehyde. Are we together now? Now there is a similar, organic compound called what? Alkanols, which is I think the one we need to know. Alkanols, or ketones. Are we there now? If you don't call it alkanols, you call it what? Ketones. Now, what is the formula for ketone? RCOR prime. Are we there now? RCOR prime. You need to know all these things, or all these particular organic compounds. Know their functional groups. Are we there now? If you don't know them, you are in soup. There is nothing that you are doing in chemistry that you don't know this particular functional group. Try and know them. It's very, very essential. Are we there now? Because there are a lot of questions. I think I've seen few though. where we have all these questions. They might not ask you which functional group is it. They might just draw a structure and then ask you which of the following is not, correct. And then if you are very careless, all of them might look the same. That's why you have to open your eyes and make sure that you know the one that is which. So this is alkanols. Now what it means is RCOR prime simply means we have R starting with R and its CO comes in between and R usually ends it. Are we together now? We start with R, CO comes in between, and then R usually does what? Ends it. Are we together now? Say for instance, I can have something like this. I can have, let me say CH3, and then I have CO, and then I have CH3. Let's draw it in open structure. I'm going to have something like this, CH3. I'll have C. The O is usually double bond O. Are we there now? So I'll come here, C. I'll have H and H. Are we together now? So if I come here, I will name 1, 2, 3. Remember, this is CH3. This is CH3 here. This is C double bond O. This is C double bond O. This is CH3. This is CH3. Are we there now? So if I want to name this particular compound, I will say this is what? Prop. Because the family is prop, so it's prop 2-on. You don't mention, you write it as 1, O-N-E-1. But when pronouncing it, you write it as what? On. So prop 2-on. Are we together now? So I can also have something like this. I told you that RCOR. I can also have my R. Let me use RC2H5. And then I have CO. And then I use CH3. Are we there now? RCOR. R starts from the beginning. CO comes in between. Also ends with what? R. Do not forget that. So I can have something like this. C, which is C2H5. So this is C2H5. And then I'll have CO. CO simply means C double bond O. There is no hydrogen that will come to this particular carbon atom that has a double bond. Are we together now? So I will now have something like this, CH3. Are we there now? So if I'm naming, I will make sure that this particular O comes to the carbon atom with the list. So I'm going to have something like this, 1, 2, 3, 4. Are we there now? So the name will be what? Butan 2O or But2-on. Butan 2-on. Are we there now? That's the name of the what? Of the alkanols. Or you say But2-on. If you don't say Butan 2O, you say what? But2-on. It's still the same thing. Are we there now? So generally, if you come here now, I can also have, say for instance, if we have something like this, let me use alkanol, let me use C3, let me use the alkane rather, not alkanol. Let me use C3, H7, and then I have CO. Are we there now? C3H7, CO, and then I have C4, H9. These are alkane, CO, alkyl. So what is the name? Well, first of all, we'll draw the structure. We'll come here, we'll do open structure. Opening structure, I'm going to have C, C, C. I've drawn C3, H7. 1, 2, 3, 4, 5, 6, 7. And then I come here, I'll write C double bond O. I will come and write C4. C, 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 C. Are we there now? Remember, this is alkanols. And in alkanols, we're not giving, alkanols doesn't end with R. Alkanols ends with O-N-E-1, like 1. Are we there now? The ones that end with R, A-L, is what? Aldehydes or alkanas. So I'll write here, I'll come here, I'll write 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to name. Where will I start from? The right or the left? I will check. If I start from the left, remember, this is the functional group, CO. I must make sure that this CO comes in a place whereby, the carbon atom is lesser in number. So if I start counting from here, 1, 2, 3, 4, that means my functional group is in the 4th carbon atom. If I start counting from here, 1, 2, 3, 4, 5, my functional group is in the 5th carbon atom. That means I'm starting from the left. So I will say 1, 2, 3, 4, 5, 6, 7, 8. Are we there now? So I'm going to have what? Octa, 4-on. Or you say oct 4-on or oct 4-on. Are we there now? Or octan 4-on. We are still in the same, direction. Octa 4-on, oct 4-on, octan 4-on. we are still what? In the same direction. Are we doing that? So these are what we mean by, aldehyde, ketone, esters. Remember, if you've forgotten, and aldehyde, we started with what I started with. I started with alkanols, and then I told you that when we're talking about alkanols is what? ROH, which is what? Alkanols. Do not forget this functional group. You will see it in your exam. I prophesy. You must see it. They understand. So please don't take it for granted. So this is ROH, alkanols. Now we have ROR, which are what? S. Is it esters? No, ethers. Ethers. Are we there now? You either call ethers, ROR, or you say R prime O R prime, ethers. Are we there now? So these are alkanols. I told you that we have 3 types of alkanols: monohydric, dihydric, and what? And trihydric. And I told you that under monohydric, we have what? Primary alkanols. Why is it primary alkanols? Because the OH group is attached to the what? Primary carbon atom. What is the primary carbon atom? Primary carbon atom is that carbon atom that is attached to only one carbon atom and other substituents. Are we there now? Like your what? Ethan 1O. Right? Now we have secondary alcohols. What are secondary alcohols? Secondary alcohols are alcohols that have their OH group attached to the what? Secondary carbon atom. Are we there now? Like propan 2O. Are we together now? Now, tertiary alcohol. Tertiary alcohol are alcohols that have their OH group attached to the what? Tertiary carbon atom. What are tertiary carbon atom? Tertiary carbon atom are carbon atom that has what? 3 different carbon atom bonded to it. Are we there now? Like 2-methyl propanol. Are we there now? So, okay, 2-methylpropan 2-ol. I think that's the word. 2-methylpropan 2-ol. Let's check for that tertiary. Let's confirm. In tertiary, you can have something like this: C, and then I have C. I have OH. This is tertiary because this particular C is bonded to this C, and this C. So if I'm naming now, this will be 2-methyl 2-propanol or 2-methylpropan 2-ol. So this is tertiary alkanol. Are we there now? So we'll move on to dihydric, and in dihydric, 2 OH group. In trihydric, 3 OH group. And then we come to ethers. I told you that is alkyl group plus another alkyl group, but the only thing holding them together is what? Oxygen. Like where we have dimethyl ether, are we there now? Or methyl ether. We also have diethyl ether or ethyl ether. We have propyl ether or dipropyl ether, and you continue. So far as it's an arrow group, it must not be the same. But so far as it's an arrow group, you can have methyl here, have ethyl here. It must not be the same. So far as OH group is holding the 2 arrow groups together. I believe by now you should know arrow group from 1 to 10. If you don't know it, please go and know it. Are we there now? The first arrow group is methyl, followed by ethyl, propyl. Know it up until 10. Are we there now? So if you don't know it, go and learn it. No time. Your exam is almost approaching, less than 2 weeks. Are we there now? So these are ethers, and then we'll say we also have something like this: ROCOOH, which are what? Alkanoic acids. Are we there now? Alkanoic acids. If you don't call them alkanoic acids, what are you going to call them? The most common alkanoic acid is ethanoic acid. Are we there now? So this is alkanoic acid. I told you that we usually write it this way: R, single bond C, double bond O, single bond what? OH. This is how it should be. Anything that is not like this in your past question, please turn your eyes the other side. This is alkanoic what? Acid. I told you we also have something like RCOOR prime, which are what? Alkanoids or what? Esters. This is ester. This is ester. This one is ether. There are difference between both of them. Are we there now? And I told you that when we are naming esters, we start from the what? The back. Do not forget, please, in God's name, I beg you. Try not to what? Forget. Even if someone is pushing you to forget, do not forget. You start naming from the what? You start naming from the back. Are we together now? Now, if we've done this particular alkanoids, now the next thing here is what we call what? RCHO. Now, what is RCHO? RCHO is what? Aldehyde. If you don't call it aldehyde, what do you call it? You call it alkanals. Are we there now? If you don't call it alkanals, you call it what? Aldehyde. In naming them, they usually ends with Al, butana, pentana, hexana. Are we there now? Ethana. Right? Now, we also have RCOR or RCOR prime. This is what? Ketones. Or what? Alkanols. You don't call them ketones, you call them what? Alkanols. So these are some important organic compounds I want you to know. Understand the esterification. I've told you that esterification is a process we use in formation of what? Formation of esters. Esterification is a process whereby we used to form what? Form esters. When we have alkanoic acid plus what? Plus an alkanol to form what? An ester and water. That's esterification. And the saponification is alkaline hydrolysis of long chain, lipids. Or long chain esters. Are we together now to form what? Soap and glycerols. So generally, these are organic compounds I want you to, go through, learn them. It is very, very essential that you go through them. Even though we have some other things I want us to do in chemistry, I know that some of you haven't still understood the, how to balance, redox equation. Redox equation. Should we leave redox equation? My pen is not writing. What is happening? All right. Redox equation. Maybe I will change. So should we do redox equation now, or maybe in our next conversation we'll do redox equation? I want to hear you in the comment section. Just what do you think? I want to teach redox equation. Should we leave it maybe next time in our next conversation? If you are okay for us to do redox, type redox. If you're not okay, say next time. If you are okay for me to teach redox equation and the balancing, type redox. If you're not okay, say next time. Let me hear you. I'm waiting for your reply or response. If you are good, say redox. If you are not okay, say next time. Okay. All right, now let's see what we can do. Let's try as much as possible to do that redox equation. Now, there are stuff you need to know. We are done with that organic chemistry. The other stuff you need to, do is go through them, read them again, go through past questions, look at organic chemistry, questions relating to organic chemistry, solve them. If you don't understand, solve and, ask me question. That's why you have my number. You ask me any question in organic chemistry that you don't understand. How to name compound. I've taught it in my other class. The day I started with organic chemistry, I explained it completely. So please go through and then, study them. Are we there now? My job is to teach you. Your job is to read. Are we there now? So please try your best. Focus more. Give yourself time. And I know you can do well. Are we there now? I know you can. And I believe. So now, just to refresh our memory, when we're talking about redox equation, is reduction oxidation. More like reduction and what? Oxidation. Are we there now? Those are two things we need to understand. Now, why we are talking about reduction and oxidation, I will not have to waste your time to, start asking you, okay, write this note or that. We'll just teach you how to, one, identify a reducing agent, and another one, how to identify what? An oxidizing agent. Now, let's start with the simplest one. When we're talking about, we have what we call OIL, and then we have what? RIG, just as I said. When we're talking about OIL, OI simply means oxidation. Oxidation is loss of electrons. Reduction is gain. Are we there now? Reduction is gain, oxidation is loss. Reduction is gain, oxidation is what? Loss. Oil and RIG. Do not forget. Now, generally, when we're talking about oxidizing agent and a reducing agent, now, a reducing agent is a species that is oxidized. An oxidizing agent is a species that is reduced. I'll go again. A reducing agent is a species that is oxidized. An oxidizing agent is a species that is what? Reduced. Now, take for instance, let me go straight to the point. Let's take for instance, we have maybe sodium plus chlorine. They are going to form NaCl. Now in the question, they can say, identify the oxidizing. I told you I'm going straight to the point. We don't have time to, mesmerize. Identify the oxidizing and reducing agent. That would be the question. Identify the oxidizing and reducing agent here. Now, if you come here, you begin to see this is sodium, right? This is chlorine. This is sodium. This is what? Chlorine. Now, when we're talking about oxidizing and reducing agent, whenever you have a singular metal, whenever you have a metal, the oxidation number of that particular metal is 0. Metal, non-metal, transition elements, metalloids, what's it called? Halogens, any element in the periodic table, whenever they are isolated on their own, be it monoatomic or diatomic, their oxidation number is usually 0. So the oxidation number, because this sodium is on its own, the oxidation number is 0. Because this chlorine is on its own, the oxidation number is what? Is also 0. Now, if we come here, what is the oxidation number of chlorine here? Chlorine here is -1. If here is -1, what will be the oxidation number of sodium? +1. Do you know why it's -1 and this one is +1? Now, let me take your mind somewhere. Remember in chlorine, what is the atomic number of chlorine? 17. Chlorine is 287. For it to be 287, this is what it means. It simply means that we have here is 2, here is 8, and here is 7. 1, 2, 3, 4, 5, 6, 7. That means chlorine needs one more electron to complete its what? Its octet structure. That is why it is -1. It needs one more electron. So it is lacking 1. It needs one more electron to complete its what? Octet structure. That's why it's -1. And if here is -1, how do we calculate the oxidation states here? We say to calculate oxidation states, we say Na plus bracket -1 is equal to 0. So Na -1 is equal to 0. That means Na is equal to what? +1. Because when -1 crosses the equality sign, it will turn to what? +1. So that is why here is +1. Here is what? -1. So oxidation states, if it moves from 0 to +1, the oxidation number, does it increase or does it reduce? If we move from 0, this is sodium. We move from 0 to +1. There is what? Increase in what? Increase in oxidation number. Increase oxidation number. Increase what? Oxidation number. Are we there? Now, if we move from 0 to -1, that is decrease. Because 0 is greater than -1 now. So this is what? Decrease in oxidation number. Now, in this situation now, here is from 0 to what? To -1. So if we move from 0 to +1, is it oxidation or reduction? Since we move from 0 to +1, this particular man is what? Is oxidation. Am I right? If we say increase in oxidation number, this should be what? Oxidation. Abi? If we say decrease in oxidation number, it will be what? What will it be? Will it be reduction? It will be reduction. So, because we have increase in oxidation number, that means sodium here, what happened here is what? Oxidation. Oxidation. I hope you can see what I'm writing. What happened here is what? Oxidation. What happened here is what? Reduction. Now, because this man undergoes oxidation, this Na is called what? A reducing agent. A reducing what? Agent. And because this man undergoes reduction, this particular Cl is what? An oxidizing agent. Oxidizing what? Agent. So, to answer the question, I will say that my Na is my what? Reducing agent, whereby my Cl is my what? Oxidizing agent. And just a pro tip, when you are identifying a reducing agent and an oxidizing agent, the reducing agent and an oxidizing agent, what we are trying to talk about is this. I want you to understand something. If a particular element undergoes oxidation, that particular element is a reducing agent. If a particular element undergoes reduction, that particular element undergoes what? Is a what? An oxidizing agent. And both your oxidizing and reducing agent are usually at the side of the reactant, not the product. Your oxidizing and reducing agent are towards the side of the what? The reactant, not the product. Are we there now? The reactant is at the left-hand side. The product is at your what? At your right-hand side. Let's do this. Let's do this again. Say for instance, we have which question? Let me get a question. Okay, let's say we have something like this. Let me use Zn plus Cl2 to give ZnCl2. Now, the first thing you have to understand is that, we have what we call, the element. And I told you that when we are talking about elements, their oxidation number is usually what? It's usually 0. Are we together now? The oxidation number of elements are usually what? Are usually 0. So in this scenario now, the oxidation number of my zinc is 0. Because this is also an element on its own, it's not bonded to any other compound or element. So the oxidation number here is also what? Is also 0. Are we together now? So because it's chlorine, the oxidation number is also what? Is also 0. So here we have what? We have 0. Are we together now? Now, if we come to ZnCl, just a minute, let me arrange my stand. Now, because we have ZnCl, now ZnCl is a product, right? Now, first of all, we'll identify what's the oxidation state of Cl. Already we know it's -1. And -1 times 2 is what? -2. So let me calculate the oxidation state of zinc. I will go back. I will tell you, say, Zn plus, anywhere I see Cl, I'll put -1 times 2. Because of these 2 is equal to 0. I will say Zn -1 times 2 is what? -2 equals 0. So Zn crosses over, will be Zn equals what? +2. So that means this is what? +2. Are we there now? So when we move from 0, zinc moves from 0 to what? +2. That is increase in oxidation state. Because when you are poor today and then you are rich tomorrow, you have increase in life. Are we there now? So this is increase in what? Oxidation state. And then if you move from 0 to -1, it's also decrease. So this particular man that increases in oxidation state is what? Oxidation. And because it's oxidation, it is what? A reducing agent. Are we there now? So zinc is what? A reducing agent. And ClO moves from 0 to -1. And because it decreases in oxidation, it is going to be what? Reduction. Reduction. And it is what? An oxidizing agent. An oxidizing agent. Are we there now? Let me give you a simple one to solve. Identify the oxidizing and reducing agent before we enter into, the 3 basic, forms of balancing redox equation. Now, let's say I have something like this. Let me say I have H plus Cl to form HCl. Identify the oxidizing and reducing agent. You have 1 minute. Everybody solve. Give me the answer. Which one is the oxidizing agent and which one is the reducing agent? And I told you that oxidizing and reducing agent usually come from the left-hand side, not here. You cannot have HCl as your oxidizing or reducing. Your oxidizing and reducing will be in the reactant side, which is your left-hand side. So solve and give me the answer. I'm waiting. It's not difficult now, is it? All right, let me come in. Now, if you look at my H, what is the oxidation state of this hydrogen? Because it's an element, the oxidation state, virtually, I told you, is 0. Are we there now? This is chlorine. What's the oxidation state? Virtually, it is 0. Are we together now? Now, what I will do is, I will come here. This is -1. If this is -1, chlorine, hydrogen should be what? +1. Are we together now? So when we move from 0 to +1, it is what? Increase in oxidation state. Increase in oxidation state. Are we there now? So increase in oxidation state is what? Is oxidation. Increase in oxidation state is what? Oxidation. And if hydrogen undergoes oxidation, that means hydrogen is what? A reducing agent. a reducing agent. So from 0 to -1 is decrease in oxidation state. Now, if this is decrease in oxidation state, this is what? Reduction. And if it is reduction, it is what? An oxidizing agent. An oxidizing agent. Okay, example. Example 4. Now, let's look at something. Look at this question. Now, this question comes where they say, using half reaction. I want us to balance this particular, redox using half reaction. Okay, thank you. Oxidizing agent is chlorine, while reducing agent is hydrogen. You got it right. You got it right. Now, I want us to, use half reaction to solve questions. We are advancing a bit. We are done with a primary school redox reaction. Let's advance a bit. Now, look at this question. They say Al plus Ni2 plus will give us Al3 plus, are we there now? Plus Ni. They say use half reaction to balance. Now, most cases, they might not ask you to balance because this is jam. Nobody has time to ask you to balance anything. We're not solving. It's why student that will be talking about balancing here. But we'll do it anyhow. Although we'll still do it. That's what I mean. Not anyhow. We'll still do it. Now, in balancing, they can give you this kind of question and then they ask you, identify the oxidizing and reducing agent. Are we together now? Now, under balancing redox reaction, we have 3 redox reactions. We have neutral redox reaction, we have acidic, and we have what? Basic. Okay, Samuel, you said, can I say that a chemical redox reaction, when you have a metal and a non-metal, yes, we can. Yes, we can. Yes, we can. Because when we're talking about metals, what metals does is that metals usually, try as much as possible to give out electrons. And when a metal gives out electrons, that's when we begin to talk about, say, they are usually positive. Are we together now? Of course, we can. And non-metals try as much as possible to, accept. Are we together? Of course, we can. But most of the time, the technicality is beyond this particular assumption that you gave, Mr. Samuel. Are we there now? That's why I try as much as possible to use oxidation state. But in almost everything, it usually happens. Are we there now? Most of the time, that is, the principle that we use. Are we there now to answer it in a simpler way? But generally, I love following my, steps and all so that we can get it. But you are still not wrong. Are we there now? But when you don't have any other, if your back is against the wall, please, you know what to do. I hope that makes sense. All right. So, if we have this particular stuff, aluminium, nickel, and then, we have this particular stuff, and then they ask us, okay, we should try as much as possible to balance using half reaction. If you look here, aluminium, what's the number of aluminium? 1. What's the number of aluminium? 1 here. The charge is 3 plus. Aluminium, no charge. But total charge in the right-hand side is what? 3 plus. In the left-hand side, 2 plus. So that means we need to balance the charge. Are we there now? So when we're talking about half reaction, what we'll do in half reaction here is that we'll take out aluminium. We say aluminium will give us what? Al3 plus. Are we there now? Aluminium will give us what? Al3 plus. We're talking about half reaction. Are we there now? We're talking about what? Half reaction. So for us to, because here the charge is 0, here is 3 plus, we have to make here to be 0 so that here will also, be 0. Because here is 3 plus and here it should be 0. So we need to make here this 3 plus to be 0. So what we are going to do, we are going to minus 3 by adding 3 electrons. So we are going to say Al will give us Al3 plus 3 electron. Now, whenever electron is at the right-hand side of your half reaction, that particular element undergoes what? Oxidation. That particular element undergoes what? Oxidation. And if it undergoes oxidation, it is called which agent? A reducing agent. So aluminum here is what? A reducing agent. Are we together now? So we've balanced the number of aluminum. If I come to nickel, Ni 2 plus will give me Ni. I need to balance the charges. So I'm going to add 2 electrons here so that we'll have, 2 minus 2 so that the charges will be 0. Here will be 0. So I'll add Ni 2 plus 2 electron to give me what? Ni. Are we there now? So whenever electron is at the left-hand side, that particular element undergoes what? Reduction. Are we there now? And if it undergoes reduction, it is what? An oxidizing agent. Are we there now? If it undergoes reduction, it is what? An oxidizing agent. Are we there now? Amazing, amazing, good. So what we're going to do here is this. We're going to now, because the number of atoms are balanced, charges are balanced, so we need to combine. Already, remember in the first reaction, we have Al will give us Al3 plus 3 electron, and then I have Ni2 plus 2 electron to give us what? Ni. Now, because here we have 2 electrons on the left-hand side, we have 3 electrons on the right-hand side, we have to, try as much as possible to cancel out the electrons. Now, because the electrons are in different values, are we there now? I'm trying to balance the reaction. Because the electrons are in different values, what I'm going to do is I'm going to multiply each of the electron by the opposite coefficient. So because this particular man here has 3 electrons and this particular man has 2 electrons, I'm going to multiply equation 1, that's the reaction 1, by 2 electrons, and reaction 2 by what? 3. Are we there now? Because this is 3 electrons, this is 2. So I will use 2, which is down, to multiply up, and use 3, which is up, to multiply down. So when I multiply everything here, I will have, here by 2, I will have 2Al will give me 2Al3 plus 6 electron. The second one, I will have 3Ni 2 plus 6 electron will give me 3Ni. 6 electron cancel 6 electron. So what do I have here? I now have 2Al, reactant to reactant. I'm combining the reaction now. 2Al plus, are we there now? Plus what? Plus 3Ni2 plus, what will it give me? 2Al3 plus 3Ni. Now let's check if the particular number of atoms and charges are balanced. If I come here, what's the charge? Number of aluminum here is 2Al. Here is 2Al. Number of nickel is 3. Number of atoms of nickel here is 3. The charges at the left-hand side is 3 times 2 plus 6 plus. The charges at the right-hand side, 2 times 3 plus 6 plus. So this particular reaction is balanced. I've used half reaction to balance this reaction. Now the question is, which one is oxidizing agent? Because aluminum undergoes oxidation, aluminum is what? A reducing agent. So Al is reducing agent. Al is what? Reducing agent. Now, because nickel undergoes reduction, nickel is what? Ni is what? Oxidizing agent. Ni is oxidizing what? Oxidizing agent. Are we there now? So that is that. Now, this is what we call normal balancing, right? Normal reaction in terms of redox reaction, the normal reaction, neither acidic nor basic. Now, I want us to advance a bit. Maybe let's try as much as possible to look at the basic and then the acidic. I think that's where we'll stop, right? We'll look at the basic and then we'll look at acidic, and then we'll call it a morning or a day or an afternoon or whatever. Now look at this example 2. We say Zn, it should be example 5. Zn, right, plus Bro3 minus will give us Zn 2 plus Br minus. We say using half reaction. Now in this situation, this is going to be an acidic balancing. Are we there now? This is what? I don't know if it's acidic or basic, but let's check. In basic, okay, let me give you a particular rule. When we're talking about acidic and basic, in acidic, we usually add H plus and water. That's acidic. In basic, we usually add OH minus and what? H2O. Are we there now? Good. So it's actually a long shot. Are you still in the mood? I hope you guys are following. If you are following, let me see your hand. If you are following, let me see your hand. Let's know if we can continue. Abi, if you're tired, we can stop here. Next time we'll continue with acidic basic and how to balance oxidation number. Okay, you guys are following. All right. Now, if you look at this particular, compound, this is Zn plus BrO3 minus. Now, in this situation, they ask us to balance using what? Using half reaction. Now, as you are balancing, remember that for you to even balance, you must try as much as possible to, understand that you are going to, try as much as possible to identify, their oxidizing and reducing agent. Are we there now? You must identify their what? Oxidizing and what? Reducing agent. So first of all, we use half reaction. Using half reaction, what I'm going to do, I'm going to take out Zn to give me, are we there now? Zn to give me what? Zn2 plus. Now, remember this is half reaction. Like elements will go together. So let's first of all balance. The charges are not balanced. So that means we add electron at the right hand side. So that means Zn will give me now Zn2 plus 2 electron. And I told you when we add electron at the right hand side, when we have electron at the right hand side, this particular element is what? Oxidation. This particular element is what? Oxidation. It undergoes oxidation. And if it undergoes oxidation, it is called what? A reducing agent. I hope you are following. If it undergoes, I said if the electron is at the right hand side, that element undergoes what? Oxidation. And if it undergoes oxidation, that particular element is called what? An reducing agent. Are we there now? Or a reducing agent. I think that's the word. A reducing what? A reducing agent. So I have balanced for my half reaction, I've balanced that of zinc because the charges are balanced, the number of atoms are balanced. So let's move on to the other half reaction, which is BrO3. So I will say BrO3 minus plus. Okay, will give me, not plus, will give me Br minus 1. Now, first of all, I will check. Here I have 3 oxygen. Here, do I have any oxygen? No. That means I have to have 3 oxygen here. And for me to have 3 oxygen, I will need to add what? H2O. I told you that in acidic, we add H plus and water, or OH minus and H2O. But in this situation, there is no OH. We are only seeing oxygen. So that means there's possibility of adding what? H plus and what? H2O. So I have Br. Look up, don't be distracted, because if immediately you look out, you might miss. So please focus. Now we have BrO3 minus. Will give us Br minus, right? Now I said, if by any chance, we have this Br is the same. But if you look at here, we have O3, and here we don't have O3. So what do? We need to introduce O here. And introducing O doesn't mean that we just take any O. Rather, what we are going to do, we are going to add water. So we are going to say BrO3 minus will give us Br minus 1 plus 3 moles of H2O. Why do we add 3 moles of H2O? We added 3 moles of H2O such that we can have 3 times O, 3O. Because here is what? 3O. Are you following what I'm doing here? So this is BrO3 minus. This is Br minus 1. I need to make, here is 3 oxygen. I need to make here to be oxygen. In redox reaction, we don't just add oxygen. Are we there now? Rather, we add hydrogen and what? And then we try as much as possible to add either H2O or hydrogen and what? H2O. So what we're going to do here, we'll add 3 moles of what? Of water, so that I have 3 oxygen. But if I add 3 oxygen here, that means here, I now have 6 hydrogen. That means I'm solving this problem and then I'm creating another problem here. So here, I'm now having 6 hydrogen. So what I'm going to do, I'm going to have BrO3 minus. Because I want to make, because here is 6 hydrogen and here is not 6 hydrogen, I will just introduce plus. 6H plus will give me, because that hydrogen is what? 6. Are we there now? The number of hydrogen there is what? Is 6. So I will just have 6H plus will give me Br minus 1 plus what? 3H2O. Are we there now? Now, if you look at this particular, reaction, you see that the number of atoms are balanced. Here, I have 1Br, 1Br, O3, O3. That's from 3 moles of water. And here I have 6 hydrogen and 6 hydrogen. But the charges, are they balanced? No. So we need to balance the charge. That's redox reaction for you. Redox reaction not be by atoms and all. No, we have to balance the charges as well. So in this scenario now, what I'm going to do here, I'm going to try as much as possible to balance the charge. So if here is 6 plus and here is minus 1, that means the total charge here is what? 5 plus. Because look up, this is hydrogen plus. 6 times this plus will be 6 plus. And this is minus 1. So minus 1 plus 6, I'm having 5 plus at the left-hand side. And here I'm having what? Minus 1. So what am I going to do here? I'm going to make sure that all the charges here is equal to what? Minus 1. That means I'm going to add an electron here. Are we there now? So what I'm going to do is that because minus 1 and minus 1 are the same, what I'm going to do here, I'm going to introduce 6 moles of electron, so that 6 moles of electron will cancel out this 6 plus here, so that we'll still have minus 1 and minus 1 as the charge. So going forward, I'm going to have BrO3 minus plus 6 hydrogen plus 6 electron will give me Br minus 1 plus 3H2O. The number of bromine, O3, 3O, 6H, 6H, charges minus 1 plus 6 is plus 5. Plus 5 minus 6 is minus 1. So the total charge here is minus 1. So this particular half reaction is what? Is balanced. So what I'm going to do is I'm going to look for a way to combine. I'm going to look for a way to what? To combine. Now, for me to even combine this reaction, I will try as much as possible to look at, okay, back to business, combining, or before we combine is an expensive word. Before we combine, let's look at here. If you look at the first part, let me write down the reaction, the other reaction. We have Zn to give us Zn 2 plus, plus 2 electron, and I say that was oxidation. Why is it oxidation? Because electron is at the right hand side. Meanwhile, this man, BrO3 minus plus 6H plus 6 electron, what will it give me? It will give me Br minus 1 plus 3H2O. Are we there now? So this and this one is balanced, this one is balanced. So if you look at the number of electrons here is 2 and here is 6. Are we together now? Here is 2 and here is 6. On a normal day, what we would have done is, well, before we move on to what we do, because electrons are at the left-hand side, this man is what? Reduction. Are we there now? This man is what? Reduction. That means this BrO3 is what? It's an oxidizing agent. But before we come there, we are coming. So let's continue. We'll move on. We'll come here. We'll say, for us to combine this reaction, we need to look for a way to cancel out the electrons. The first one, electron is 2 minus. Are we there now? The electron is what? Is 2 minus. So we need to look for a way to make this particular, electron to have the same number. Are we there now? Simpler ways that would have used 6 to multiply and then use 2 to multiply here. But it will be an expensive number. So why not, since they are divisible by each other, 2 and 6 are divisible. Why not use 1 and 3? So say use anything here, we use 1. Everything here, we use 3. Are we there now? You getting what I'm saying? I said, let me come again. Look up now. Look up. Let me be slower a bit. I said, we want to cancel out these electrons that are here. For us to cancel out these electrons, what are we going to do? In simpler, redox reaction, we would have used this 6 electron to multiply everything at the first hand, and use these 2 electrons to multiply everything at the downside. It is acceptable. But because this particular 2 and 6 are divisible by each other, 2 into itself is 1, 2 into 3, 2 into 6 will give us 3. So what we are going to do, because we have 1 and 3, I'm going to use this 3 down here to multiply everything up, and use this 1 to multiply everything down. Are we there now? I think that's simpler. So what I'm going to do here is this. I'm going to use 3, multiply everything. I'm going to have let me multiply the first by 3 and second by 1. by 1. Are we there now? So what I'm going to do, I'm going to use 3Zn will give us 3Zn2 plus 6 electron. And everything here by 1, that means it's still the same thing. BrO3 minus plus 6H plus 6 electron will give us Br minus 1 plus 3H2O. So 6 electron cancel 6 electron. Remember, the goal is for the electrons to cancel out each other. So 6 electron cancel 6 electron. I'm going to have 3 zinc plus, that's combining the reaction now, reactant to reactant, product to product. 3 zinc plus BrO3 minus plus 6H plus will give me Br minus 1 plus, are we there now, plus 3H2O. Are we there now? I say this is 3Zn plus, okay, I didn't add 3Z plus 3Zn2 plus 3Zn2 plus. Are we there now? So in this scenario now, the charge is here is 6 plus. Are we there now? Here is 6 plus minus 1, that's 5 plus. Here is 6 plus minus 1, 5 plus. So the charges are balanced. 3 moles of zinc, 3 moles of zinc. 1 mole of bromine, 1 mole of bromine. 6 oxygen, 6 oxygen. Is it 6? 3 oxygen rather, 3 oxygen. 6 hydrogen, 6 hydrogen. So this is what? A balanced reaction. And what is the oxidizing and reducing agent? It says zinc is the reducing agent. Zinc is the reducing agent, and BrO3 is the what? Oxidizing agent. If you are following, let me see in the comment section. If you follow through what I saw, just comment hi or with any emoji. Let me know that I'm talking to a human being here. Just comment hi before we move on to the last reaction, which is the basic reaction I've saw for acidic. If you look what happened here, here was hydrogen ion and OH. Are we there now? And at the end of the day, it ended with hydrogen ion and OH. Are we there now? So, and H2O rather, hydrogen ion and H2O, that's acidic. So for basic, now basic will be hydro Z and what? H2O. Now let's look at this question. Let's look at this question that they ask. Okay, look at this question. Okay, we have AG, example 6. Example 6. In example 6, the question is AG plus Zn2 plus AG plus Zn2 plus AG plus Zn2 plus will give us Ag2O, are we there now, plus Zn. So using half reaction, balance. Using half reaction, do what? Balance. Using half reaction, balance. Okay, what I'm going to do is, first of all, I'm going to balance. I will say Ag will give me Ag2O. I will then, first of all, I will add 2 atoms to this silver. I will say 2Ag. I will then add 2Ag will give us Ag2O. I will then, so I need to make sure that this particular oxygen that is at the right hand side is at the left hand side. So I'm going to introduce, oxygen here. And for me to introduce one oxygen, I'm not just going to add O. I will rather put what? H2O. So what I'm going to do here, I'm now going to have 2Ag. I will then add plus H2O, right? To give us what? Ag2O. Now, if you look at what happened here, I want you to understand. If you look at what happened here, you begin to see that here we have 2 moles of what? Ag and 1 H2O. Because Ag is 2 here, Ag is 2 here, O is 1, O is 1, but H2 is 2. We have 2 H2 and we don't have any hydrogen here. So I'm going to introduce hydrogen. So I'm going to say A2Ag plus H2O will give us what? Ag2O plus 2 hydrogen ion now Are we together? Because we have 2, because we want to make 2 hydrogen ion. This is 2, please, no mistake. Are we there now? If you look at the charge here is +2. Are we there now? The right hand side, what's the charge? +2. The left hand side, what's the charge? 0. So we need to make the charges to be neutral. I'm talking about balancing. So what I'm going to do, I'm going to have 2Ag plus H2O. Are we there now? Will give me Ag2O plus 2H plus 2 electron. Now I told you when the electron is at the right hand side, that particular element undergoes oxidation. It undergoes what? Oxidation. And if it undergoes oxidation, it is called what? An reducing agent. Are we there now? Or reducing agent. So this particular man here is balanced. This half reaction is balanced. So move on to the next half reaction, which is what? Zn2 plus to give us what? Zn2 plus to give us, what will it give us? It will try as much as possible to give us Zn. Are we there now? Zn2 plus to give us what? Zn. So I'll come here. If Zn2 plus will give me Zn, that means I will need to introduce, charge. So I will come here. If I have Zn2 plus, so what will I do to, make the charges balance? I'll try as much as possible to add electrons. So I will say Zn2 plus 2 electron to get what? Zn. So this is balance. And if electron is at the left-hand side, it is what? Reduction. Are we there now? So what's the next step? Next step is combining the reaction together. Now let's write down the reaction first of all. The first reaction, what was the first reaction? Okay. In the first reaction, I had 2Ag plus 2Ag plus H2O plus H2O to give us Ag2O plus 2H plus 2 electron plus 2H plus 2 electron. That's the first reaction. Are we there now? Now and then the second half reaction will be Zn2 plus 2 electron to give us what? Zn. Now what we want to do is that we'll combine. Are we there now? Now combining simply means that they can easily, because we have 2 electron, they can easily do what? Cancel out each other. And when they cancel out each other, you begin to see that here we're going to combine. The left will go to the left. So I'm going to have something like this. 2Ag plus H2O, are we there now, plus Zn2 plus will give me Ag2O plus 2 hydrogen ion plus zinc. Are we there now? Plus 2 hydrogen ion plus what? Plus zinc. Are we together now? Now in this situation, I want you to understand something. Now here I have 2 plus, hydrogen is 2 plus, hydrogen, the charge is here 2 plus, 2 plus. What's the number of hydrogen here? 2, hydrogen here 2, zinc here 1, zinc here 1, Ag2 here is what? Is 2. Are we together? I don't know if you are getting what we're doing here in this scenario. Like Ag, this is 2Ag plus H2O plus zinc. Let's check if they are balanced. That's what I'm checking here. And we then look at the atoms. Are the atoms balanced? We say that Ag2, O1, O1, H2, the charge is 2 plus, 2 plus. So in this scenario, this is what? This is balanced. Are we there now? This is what? This is balanced. Now, this is still an acidic reaction. It's not a basic. This is an acidic balancing. Are we there now? This is still what? An acidic balancing. Let's get a basic balancing where we have OH. Okay, let's look at this question. A very brutal question. Al, number 7. I think this should be the last. We have Al plus ClO4 minus will give us, what will it give us? Al OH minus 4 plus Cl minus. Is there anybody that can try it? I'll give you 30 seconds. Try. Let me see if you can get something out of it before I come in. Let me see if you can get something out of it. This is your time to shine. All right. Okay. No idea. That means I should come in then. That means I should do what? I should come in. Okay. So now, for us to balance, well, first of all, we take half reaction, right? Now, as I usually say, half reaction. In half reaction, what are we going to do here? We're going to try as much as possible to say Al will go to what? Al bracket OH minus 4. Please don't be distracted. This is one of the longest one you've ever seen. So please focus, open up your eyes, don't sleep. If you think the devil is asking you to sleep, be awake. Then good things come from hard work. Lazy people are sleeping now. You are a hardworking individual, that's why you're awake. So be awake. If you have your water, you sip it, drink. Let's continue. So in half reaction, this is Al to AlOH form. Now if we come here, we look, say, this is hydroxy. I told you that in bases are usually hydroxy and what? And H2O. So in this case, we want to balance up. Are we together now? So for me to balance up, what am I going to do? So what I'm going to do here is that because I have OH4, that means I have 4, oxygen. So that means I'm going to introduce 4 oxygen here. I'm going to have Al plus 4H2O. Are we together now? Now, plus, okay, will give me Al OH 4 minus. Are we together now? Now, that is, how we generally start. Now, in this scenario, what we're going to do here is this. We're going to try as much as possible to say, okay, since I have, 4 moles of water, and here I have 4 hydrogen, but here I have 8 hydrogen. Are you getting what I'm saying? I already have 8 hydrogen, but here I have 4 hydrogen. So that means I'll add extra 4 hydrogen here. So I'm going to have something like this now. Al plus 4H2O will give us AlOH4 minus plus 4 hydrogen ion. I don't know if you are getting what I'm saying here. If you're not following, you can ask question. Are we there now? We are still trying to balance the half reaction. Are we there now? So in balancing the half reaction, we've already gotten 4 hydrogen ion. Now, if we come here, the oxygen and hydrogen are balanced. The aluminum are also balanced. But the charges, are they balanced? No, they are not. Are we together? Because here, the charges is 0. But here, I'm having minus and plus 4. So that means for me to balance here, I'm going to remove every charge. So what I'm going to do here, I'm going to say Al plus 4H2O will give us. Now, in this scenario, what we're going to do here is that we're going to say Al, open bracket, OH, 4 minus plus 4H plus. So because 4 plus and minus 1 is what? 3 plus. So what will I add here to make the charges to go away? I will add plus 3 electron. Are we there now? So that all the charges will do what? All the charges will go away. I don't know if you are getting what I'm saying. All the charges will do what? All the charges will go away. Are you following what we are doing here? So in this scenario now, we are arriving there. So this is more like, balancing the half reaction. This is the first way. I will show you something. Just work with me. The charges are balanced here. Are we there now? The charges are what? The charges are balanced. Al plus 4H2O will give us AlOH, minus 4 plus 4H plus 3 electron. The charges are balanced, the atoms are balanced and all. Now let's move on to the second one, which is ClO4. Are we there now? Minus, which to give us what? Cl minus. Are we together now? Now we have Cl, we have Cl. Here we have O4. That means we have to also make here O4. To make here O4, what will I do? I will introduce water. So I will say ClO4 minus will give me Cl minus plus 4H2O. Are we together now? So if I have 4H2O here, that means here is 8 hydrogen. Here should be 8 hydrogen too. So I will say ClO4 minus plus, here will be 8 hydrogen, 8H plus, to give me Cl minus plus 4H2O. Are we there now? So in this scenario now, I already have minus 1, and here I'm having, plus 8 and minus 1. So I need to balance the charges. So what I'm going to do here, I'm going to have ClO4 minus plus, because I need to make minus and minus to be the same. So I need to remove this 8H plus here. So that's why we add electron. 8H plus plus 8 electron, so that the charges will be balanced. So Cl minus plus what? Plus 4H2O. Now if we come here, you begin to see that the charges are balanced, as well as the what? As well as the atoms. So if I come here, I will say, okay, we have to do what? We have to, multiply. Now multiplying, what am I going to do here? I need to look at this particular man here. This is first reaction. This is what? The second reaction. So what I'm going to do here, just give me a minute. My system wants to off. Let me plug it a bit. Just a second. Okay, I've plugged it. Okay, let's continue. So if we come here, this is ClO4 minus plus 8H plus 8 electron to give us Cl minus H2O. And then look at the first reaction, look at the second reaction. Now what we're going to do here is that we want to look for a way to combine this reaction. If you look here, this is 3 electron. If you look here, this is 8 electron. So how do we cancel out these electrons? So that means we use 8 to multiply the up, and we use 3 to multiply the down. Are we together now? So that is what we're going to do here. So I'm going to try as much as possible to use, the 3 electron up to multiply the down, and use 8 electron to multiply, so that we can have, the same electron that can cancel out each other. That's the goal. That's why we are multiplying, so that the electrons can cancel out what? Each other. So what we are going to do here is I'm going to say 3 times this. I'm going to have 3ClO4 minus plus 3 times 8H plus. I'm going to have 24H plus. Are we there now? 3 times 8 plus 24 electron minus 3 times this 3Cl minus. Are we there now? 3 times 4H2O plus 12H2O. Right? I think we are done here. I'll use 8 to multiply. I'll say 8Al plus 8 times 4, 32H2O. Are we there now? To give us 8 times this, 8Al OH minus 4 plus 8 times 4, 32 hydrogen ion plus 8 times 3, 24 electrons. I hope you are following. 24 what? Electrons. Now we have here 24 electrons and 24 electrons. So 24 electrons and these 24 electrons will cancel out each other. So we'll now combine. Combining the equation, we are going to have something like this. It's a bit long equation, but let's work it together. We're going to have 3ClO4 minus plus 24 hydrogen ion plus 8Al plus 32 H2O will give us 3Cl minus plus 12H2O. How then now? Plus, am I getting it right? 3Cl. This is reactant. 3ClO4 minus plus 24 hydrogen plus 8Al plus 32 water. Okay. The product that 3Cl minus plus 12H2O plus 8Al OH minus, are we there now? 4 plus 32 hydrogen ion. Now, if you look at the charges at the right hand side and the left hand side, The charges, let's check if they are balanced. Here we have 3 times minus, 3 minus, 24 plus here, but I already have 32 plus. So that means the charges at the right-hand side is excessive. That means there is more hydrogen ion than there is, for minus. So the question is, what am I going to do here? Now, there is a particular law of what I'm going to do to balance the charges. Don't worry, I'm rounding off. So what I'm going to do to balance the charge is this. Now, remember at the left-hand side, I have something like this. 3Cl. I'm trying to write this particular question. Give me a minute. 3ClO4 minus, and then I have plus 24 hydrogen ion, now plus 8Al plus 32 H2O. Now, look at what is going to happen. What is going to happen is this. I'm going to try as much as possible. This is the half reaction. Look up. This is the half reaction that I've written down. Like, this is the half part. If you've written everything I did down here, you see I have 3ClO4, that will give us 24 hydrogen, 8Al, 32 water, and everything. But if you look at the other right-hand side, there is more of hydrogen, which is 32 hydrogen ion. It's too much. So what I will do is I will reduce the hydrogen ion here. I will reduce the hydrogen ion so that the charges can help balance. So for me to reduce the hydrogen ion, that's why it's basic. In basic reaction, this thing usually happens. So for me to reduce the hydrogen ion, I will introduce the same number of hydroxy ion here. So I will, instead of leaving 24 hydrogen, I will now introduce 24 hydroxy ion. Are we there now? I don't know if you are getting what I'm saying. Yeah, I don't know if you are following. I will introduce 24 hydrogen ion at the left-hand side and also 24 hydrogen ion at the right-hand side. Say, for instance, let me write the complete reaction. This is the half part. Let me write the other part. The other part will be something like this. I will write 3Cl minus plus 12H2O plus 8Al. I'm coming, I will show you. Plus 8Al, open bracket, OH minus 4 plus 32 hydrogen ion. Now, I've written it down. If you look here, the charges are not the same. So I want to balance the charges. So I said I will introduce 24 hydrogen. Because I have 24 hydrogen here at the left-hand side, I will introduce the same number of hydrogen to that of what? To that of the hydroxy. So I will introduce 24 hydroxy here and also introduce 24 hydroxy at the right-hand side. So I will have 24 hydroxy ion. At the right-hand side, I just introduce it. So if this 24 hydroxy ion and this, I'm going to form water. So my new reaction will be something like this. I'm going to have, in that left-hand side, I'm going to have, remember, I have 3ClO4 minus plus, it will no longer going to be 24 hydrogen, it will be hydrogen plus hydroxy is H2O. So I'm going to have plus 24 H2O plus 8Al plus 32 H2O. Are we there now? That's the first part of this reaction. Now the second part will now be this one down here, which will give me 3Cl minus plus 12H2O plus 8Al OH minus 4 plus 32 hydrogen ion plus 24 hydroxy ion. Now, if we balance, the charge must be the same. If the charge is not the same, I'll light my room on fire. So let's check. let's pray it doesn't get to that. So what's the number of 3Cl? Then Cl here is 3. Let's check at the right-hand side. Cl here is also 3. Are we together now? Now let's check oxygen at the left-hand side. O4. Are we there now? O4 plus 24. 24 plus 4 is 28. We'll come here. This is 32. 28 plus 32 should be having 58, 60. No, let's start again. 4 plus, what am I doing? This is 4, right? Is it 4? 3ClO4. Because we have this 3 molecule, 3 is affecting O4 now. So it's 3 times 4. I have 12. Please let me write this thing down. 12. This is 12O plus 24O. Abi plus 32 plus O. This is 32O. Are we there? 32O. So 12 plus 24 is 36, right? 36 plus 32, that should be 68O, right? So total of 68O. Now, if we come here, we have 12 times 2, 12O. If we come here, O times this particular 8AL is affecting O. So 8 times O, 8 times O, 8. 8 times 4, right, will be 32O. So 32O plus 24 times O, 24O is still the same thing, which is 68O. Or then 68O. That means O is balanced in the two of them. If we come here, this is 8Al, 8 aluminium. And meanwhile here, this is what? 8 aluminium. So 8 and 8 are balanced. And if we come here, look at the number of hydrogen, which is, here we have 24 plus times 2, which is 48. The number of hydrogen here is what? 48. 48. And here we have 32 times 2, 64, plus 64. Are we there now? So 48 plus 64, 100, 112. Am I right? So if we come here, and if we come here, I have hydrogen here, 24 hydrogen, 24. I have 8 times hydrogen, 8, 32, 2, plus 32, plus 32, plus 24. Are we then? I see the same thing, because 24 plus 24, 48, 48 plus 30, 48, 32, 32, 64. So 64, 48 is still the same thing. Are we there now? So the number of hydrogen are the same. Let's check the charges, which is the main issue that made us to, rebalanced. If you come here, the charge 3 times minus is 3 minus. Abi, check another charge. So that means the total charge at the left hand side is 3 minus. Confirm, please help me confirm. 3 minus. Okay. If I come at the right hand side, here I have 24 minus. Let me check. Let me start with 3 minus. I have 8 minus. I have 32 plus. I have 24 minus. So I have minus 3 minus 8 is minus 11. Minus 11 minus 24 is what? Minus 11 minus 24 is minus 35. Am I right? So minus 35 plus 32 minus 3. So minus 3 is the same as this. So the charges are balanced. So this is a typical redox reaction of acidic, neutral, and that of what? And that of basic. So yeah, I believe we are done for the night. This is where I'll be stopping. Let me do other stuff too. And if you have any question, please don't forget to comment. If you have a question, I will just leave the chat on for just in the next in the next 1 minute. If you understood, just let me know. If you don't, still let me know. Let me see. Is there a particular place you don't understand? Go through it. Is there a particular, from this explanation, is there a particular place you don't get? Let me know. Ruth Oluwakemi. Oh, Ruth, you're welcome. Thank you. So is there a particular place you don't understand? Just go through and let me know. If there's something I can say, I will say. And please, your jam is coming up. Please try as much as possible to not let this my effort be in vain. Try and read. I beg you in God's name. Oh, please, try and read. I want to be happy when you told me, or when you tell me that you scored 300. I want to be so happy. Oh, then, this particular work we are doing is not for 250. It's not for 270. It's for 300 and above. So please score higher. We are ready for this. So thank you for your time. I will, we'll come again tomorrow. We should have class again tomorrow by midnight. So have a good night. Bye for now. Okay, can I re-explain from where I added OH? Okay, you want me to re-explain from where I added OH? Okay, Ruth. Okay, what happened was, if you look at the place I added OH, what I did was, there was excess hydrogen ion. If you look at, let's go back a bit. Look at this particular place. Let's go back. If you look here, there was 32 hydrogen ion, and there was 24 hydrogen ion. If you look at the charges, the positive here was much than the positive here. If we look at the total charges, the total charge here is higher than the one here. So we needed, because it's basic, since the positive was much, we need to try as much as possible to balance the positive. And for us to balance the positive, I will add the number of hydrogen, the number of hydrogen ion, I will convert it to hydroxy ion. So since I have 24 hydrogen, I will just get 24 OH minus. I will do it. And if I get 24 OH minus, I will still add that 24 OH minus here, so that it will subsidize the amount of positivity here. That's what happened. Because generally, the charges at the right-hand side was way higher. So we needed to, subsidize or reduce, the charge. So what we did was we added the same number of hydrogen ion as per hydroxy. That's why I added 24 hydroxy. Look at what I did here. I added 24 hydroxy at the left-hand side. If you look at this 24 hydrogen, is minus. And I also added this 24 hydroxy at the what? At the right-hand side. Are we there now? So that's what helped us to solve for everything we did here. So that means when 24 hydrogen ion plus 24 hydroxy ion comes together, we now have, 24 moles of, H2O. Are we together now? We now have what? 24 moles of H2O. And then this is what we have here. Look at it, 24 moles of H2O. And at the end of the day, this particular, 24 hydroxy ion affected the charges at that right-hand side. Are we together now? Look at what we have here. After we added, we have 3ClO4 plus 24H2O plus 8Al. This 8Al you're seeing here, this is 8Al plus 32 moles of water and all. Are we there now? So that's what helped us to come down to arise to this particular point. Maybe what you can do is rewatch the video again. If you still don't get, rewatch it, come down and watch it. I re-explained it, and I hope that will be all. Thank you for your time. Have a lovely night, and good night, Ruth. Having a good night, and every other person here. Bye for now.